Jose Alatorre, and my project is going to be a Luigi problem set, exploring and extending Luigi functionality and see a real-life application. What I want to do with this project is to extend a bit for coming students or anyone that wants to explore a bit Luigi, that I think it's awesome, and check a little bit more of the functionalities and have a sense of how can it be used in a real life scenario. So what are we gonna do here? So what is Luigi, first of all? This is extract from the wise word of Spotify. How I understand it and how I see it is like it helps me to transform all my coding, all my mental representation of a problem into an interconnected graph, right? Like into divide each part of the code into very specific tasks, and then be able to control which tasks were performed and which tasks were not performed. Like personally, I think this is an amazing topic because I ended up doing a lot of nasty things myself while coding and working with different tasks. I ended up like rerunning the code and overwriting files just to get sure that they were done, right? So I think this is really going to help me from now on. It's a great tool. How we're gonna use it in this problem set? Well, this problem set actually came, and this usage came because I was building a model from an algorithmic trading deep learning model. You can check the model in that paper. And you know, when you are building an algorithmic training model, the first part is to get the data. It's one of the most important things, and given that we are doing high frequency for this project, we need very fast data. So I'm using the API from Coinbase, which only allows you to extract one request per second. In each request, we can pull around 350 values. It may seem a lot, but if we want to take months of daily 1 minute data for a few months and many cryptocurrencies, we see that this becomes a lot of data, right? Like for example, in 6 months we have like 1 hour has 60 minutes, then by 24 hours, by 6 months, by 20 currencies, we end up having around 5 million data points. So if we extract 350 per second, it means around like 4,800 extractions. You know, it's very important that this is done right, because it can happen for many reasons, that the AP didn't work, our connection went down, and if we don't have a way of controlling these extractions from the API and then these insertions to our database, we will run models erroneously, and it's very hard to debug or like try to look exactly for which part of the data is not correct, right? Because we're gonna be extracting time frames from our database. So at the end, it should look something like that, right? In this problem set, we're gonna do a very basic trading strategy, not even a trading strategy. We're just gonna calculate the correlation between two cryptocurrencies, and this is how the pipeline should look, right? We should have a task that means update cryptocurrency prices, and this task should like collect a 4-hour bar from the API, saved into disk, then read that file, update it in our database, and once that database is updated, we calculate our correlation, right? And this is done for two cryptocurrencies. Actually, I want to show you. I have here. I don't know if it's open. No, it's not. But I'm actually running it right now for 20 cryptocurrencies in 6 months, right? And the chart is really impressive. It's really powerful. This tool. So how is the problem set gonna be structured? So the problem set is gonna be structured. First, we're gonna kind of warm up with the API calls and local targets. We already have studied this, but I think it's worth it to warm up with something a bit in Luigi. Then we're gonna explore database targets, and by last we're gonna extend Luigi. We're gonna do two extensions. One, we're gonna extend Luigi to other applications. In this case, the Jupyter Notebook. I know it's not the spirit of this class to use notebooks, but I think it's a very interesting application. And we're gonna talk a little bit about the event model, And but last, we're gonna talk about what I call a logical target. That it's an interesting extension of Luigi. So first thing, setup. We're gonna please use your cookie cutter project set to start this project as usual. The libraries that we're gonna need is gonna be Luigi, it's gonna be SQAlchemy, it's gonna be String.io, CB Pro, that is an API to connect and retrieve prices for Coinbase, and Jupyter. The first problem, let's warm up a bit. So to warm up our skills, we need to create a task that retrieves 4-hour daily prices, and then this saves this to a CSV. It is important in this task that we create our files with some sort of hash. I didn't want to do the specific hash here because I like to see which file corresponds to what, right? So in this case, for example, I have Bitcoin of 2019, 9th of April at 00, and this is the granularity. It means it's 60 seconds, 1 minute. Next, we're going to explore the database targeting in SQL. I'm going to be rolling through the problems a bit here, so we know where we are. So now with the previous task, we have all our data in independent CSV files, and we can guarantee that the extraction has been completed only if the files exist. Now the next thing is, like, we want to collect this data and put it in a database, so we can do a more efficient extraction when creating algorithm. So for this task, what we're gonna do is we're gonna read the CSV files, and we're gonna do an insertion into the database. I think we already saw in class, but it's important to notice that the way Luigi knows that an insertion has been done in a database is by creating another table called table updates. And what we need to do is to modify the primary key to know which update has been done. So what you guys need to do in the problem set, or actually what I did, is to modify this primary key by the same format that I did for my CSV files, right? So date, time, and the granularity in this case. Something very important is how do we modify this entrance into the Luigi, into the database. We use the method. We use the following method in our SQL copy table. In this case, table is actually just the name of the table, that in our case is the name of the cryptocurrencies, and then I'm adding the target. Now the event model. This is something very interesting because it helps us to extend all Luigi functionality. It's just give it a look. In the task, I asked to calculate the processing time of a task. You can use it like this, extremely powerful. But now everything that we create as a task is gonna be time. By last, I have two extensions. One is Jupyter Notebook. In this task, what we should do is we should send environment variables to a Luigi notebook. The notebook will perform a certain operation and then create a file, and this is gonna be our sign that the task has been performed. What we would like to include a Jupyter notebook? Well, maybe we want to include a Jupyter notebook because there is one process that eventually we may want to debug some of the steps, and we want to have charts, and we want to have all of the nice things that we can see in a Jupyter notebook before we send to production, right? So I think it's an interesting model and shows some of the extensions that we can do with Luigi. And given that the time is running, by last, we are gonna work on a logical target. So this is a very interesting solution because maybe sometimes we want not to persist to disk. And why we will not like to persist to disk? Well, maybe we have two scenarios, right? We have a scenario that we want to run our tasks with the bookend, and this means that we may want to to drive this into this, some data frame or some pandas data frame into this, but then maybe sometimes we don't want to do it. And we want to keep all our process, all our logic, and very specific tasks inside a Luigi task. So in this part of the problem set, we are going to build a type of target, right? That it never writes to this, but like for example, we create a data frame and we want to do something with that data frame, and that's itself a task. So only when that task has been done, the next task can be executed. So I'm gonna show you these implementations of all these problems in a separate video. But well, hope you enjoy this Pset. It's fun. I have uploaded in a Git repository with all the answers, so I think it can give you a better understanding of how to use Luigi. Thank you for your time.